Hi students, today we are going to understand about Wheatstone bridge and Wheatstone principle. Kirchhoff's laws consist of two parts. Kirchhoff's first law, junction rule, law of current or law of conservation of charge, which states that algebraic sum of the current meeting at a junction is equal to 0. Kirchhoff's second law or law of voltage, loop rule or law of conservation of energy states that algebraic sum of the potential difference is equal to 0 in a network consisting of cells and resistors. Using this, we will be able to solve Wheatstone bridge. You know what is a Wheatstone bridge? It consists of 4 resistors P, Q, R and S connected as shown in figure. Across the junction B and D, a galvanometer of resistance G is connected, and across the junctions A and C, a cell of EMF E and a key is connected. When the key is closed, the current passes through each arm of the bridge according to Kirchhoff's first law. Using Kirchhoff's second law, we will be able to solve the closed loops. So first, I am going to consider the loop A, B, D, A. Applying second law, I1 into P plus Ig into G minus I minus I1 into R is equal to 0. A, B, D, A, I1 into P plus Ig into G minus I minus I1 into R is equal to 0. Now, we will consider the loop B, C, D, B. I1 minus Ig into Q minus I minus I1 plus Ig into S minus Ig into G is equal to 0. Considering the loop BCDB, I1 minus Ig into Q minus I minus I1 plus Ig into S minus Ig into G is equal to 0. Since P, Q, R and S are resistors, we can adjust the value of these resistances. So by adjusting the value of these resistances, we will get a condition where galvanometer shows 0 deflection. That is, Ig is equal to 0. At this condition, the potential at B is equal to the potential at D. Applying this condition in these two equations and solving this equation, we get P by Q is equal to R by S. That is, when galvanometer shows 0 deflection, no current passing through the galvanometer, the ratio of resistance in the upper arm is equal to ratio of resistance in the lower arm. And this condition is called Wheatstone principle. Now let's see how this principle can be demonstrated. Instead of resistors, I have taken bulbs. So P and Q are represented by the bulbs 60 watt and 40 watt. So when the circuit is on, because of the brightness of this bulb, we won't be able to distinguish how this central bulb works. Central bulb represents a galvanometer. So what I am going to do is, I am going to isolate the central bulb from the other bulbs using a paper pipe. When the circuit is on, you can see all the 4 bulbs are working, and now we will see the state of the central bulb. The central bulb is glowing. That is, it represents unbalanced Wheatstone bridge. There is current through the central bulb. You can see the ratio P and Q 60 watt and 40 watt. Now what I am going to do is I'll adjust the position of P and R. 60 watt is brought here and 40 watt is placed here. When the circuit is switched on, again the 4 bulbs are working, and see the status of the central one. You can see that the central bulb is not glowing. That is, now the Wheatstone's bridge is balanced. P by Q 40 by 40 is equal to R by S 60 by 60. So it is the balanced Wheatstone bridge. Now let's see how the apparatus look like. Instead of resistors, I have taken the bulb holders. So 4 resistors are represented by the 4 bulb holders, and the galvanometer is represented by the 5th bulb holder. And these bulb holders are connected according to the network, Wheatstone's network. Hope you understood the concept of Wheatstone bridge and Wheatstone principle.